point out about this one. Sorry, virtual students, I didn't record the beginning, but there's more examples that'll catch you up. Last thing I'll point out, our x, it is just x, right? It's not x squared, it's not x cubed, which we'll look at in a second. So when we have just x in our denominator, we see that these two functions are kitty corner, right? They're opposite of each other. Now, what do you think would happen if we put a negative sign in front of all of this? Where then would our two graphs move to? What do we think? That's not how I thought about it, but yes, it would move clockwise. They would move to these other corners, okay? So when we see, my point is, when we see just x, we should know that our graphs are going to be opposite. And, I mean, the negative will change things a little bit, but those will be opposite. Very good. When we look at our second example, and we are sketching a graph. Let's see, Gabby did this one. And she did a nice job. We call this graph the volcano because it's kind of going up like a volcano. And just based on what we've talked about so far, where would the two asymptotes be? Well, one of them would be at -3. Oh, and I did not write this one correctly, and I changed it in my notes, but not in yours. Sorry. That's what I wanted. So go ahead, plug it in your y equals a second. Plug in your y equals. I need to make a note. Fix. This is... So in your calculator, I would put it in like this. So put it in just like this. And I remembered my divided by this time. So that should help. Now, when we already know that this end number affects that we're moving up and down. Now, the value that's attached to the x, x always lies, right? So naturally, we would think that we move 2 units to the right, but where does it show that things shifted? Yeah, to -1. So now our asymptotes, x equals -1, y equals -3. And you can see with the graph that Gabby drew here, she moved it over from the origin just a little bit, and this was probably -3, what she was getting at here. And she showed that it approaches -3, but it won't touch -3. Our graph will not. It'll get close and close and close, like all the way up to 2.9999, as close as it can get, but it will never touch -3. Same thing with -1 with our x values. Now again, if we threw a negative sign in front here, what would that do to our graph? Yeah, we'd have an upside down volcano then. Yep. So again, when we see, like I talked about in the last one, when we see that something, that we have just x, not raised to a power, we're looking at those opposite graphs. When something is squared, the parent function of this would be g of x equals 1 over x squared. When something is squared, we're looking at a volcano. Now let's look at when something is cubed. So Ryan had that they were on those opposite sides again. Why don't you all plug that into your y equals? You shouldn't even need any parentheses. You can throw them in if you want, but you don't have to have them. Now in this case, x, we don't have like x plus 1 cubed or anything like that. All we have is x. So what would one of our asymptotes be?
0.
Yep. I guess. Well, negative 1 would be, like y equals negative 1 would be if something were happening over here. But our graph doesn't move up or down, right? Because we're not adding or subtracting anything on the end.
Y equals 0 too.
So our asymptotes would be x equals 0 and y equals 0. With the cubed, notice that we are opposite again, okay? So when we looked at our first example, I mean, really we could have written this as this stuff raised to the first power, right? X is raised to the first power. We don't write it because it doesn't do anything. But what we should see and start to understand with functions is that if we have x and it's raised to an odd number, then we're looking at those kitty corner graphs. If it's raised to an even number, that's where we have the volcanoes. Now, a little different things happen because, like with a parabola, that's squared. So that looks like the parabola. But in this case, x will be in the parenthesis or in the denominator. So we should, when we graph these, we should have an idea of what it should look like just based on what that exponent is. Now, if you take a look at your packet, number 3, it is this exact one. So why don't you sketch that graph for number 3. Notice in the top in the directions, it wants you to write the asymptotes, which we've already done, the intercepts, which we'll get to in a second, and sketch a graph. So we've already done 2 of those 3 steps. You can cross out. I don't know if it's crossed out on yours or not. And behavior you do not need to do because we kind of take care of that with the asymptotes and intercepts. Well, asymptotes. So sketch that graph, just write what those intercepts or what those asymptotes are. Now, the only thing that we're missing is the intercepts. In this case, correct, there are no intercepts, right? Because it'll approach y equals 0, but never cross it. It'll approach x equals 0 and never cross it. So we have none, and we have none. If we look at this first example that we talked about, how would we find the intercepts? Now, this isn't one on your page unless I did that on accident. But let's just go through for a second how we could find the x and y intercepts. If we wanted to find the x-intercept, how would we even begin to do that? Yeah, Ryan? We could look at the table. Yeah, that would probably be my first go-to. Well, I have too much stuff written on here. I really should not have this. So we could look at our table, right? That's probably the first thing that I would do. Look at the table, see if I can find an x-intercept. What would I look for in my table? Like, what would y have to equal for my x-intercept? Y has to equal 0. So I could look at my table. I'd be looking for where y is 0. I also could set up an equation and solve, right? I know that y has to equal 0, so I could solve to see what that x-intercept would be. Now this looks like a lot, doesn't it, to solve? But it's not too bad, especially if we think about our cross multiplying. And we could solve. Pretty sweet. Now our y-intercept might be a little bit easier. Did anyone look in their table? -1? Is that what we would get? Yep. We would. Now, when we're looking for a y-intercept, what does x have to equal? Yeah. So y equals 3 over 0 minus 2 plus 1. This might be a little easier to solve. Yep. So our y-intercept then would be -1/2. Okay, and hopefully when we sketch our graph, hopefully our graph reflects that, or the graph that we draw should reflect that. Okay. I'm not looking for these graphs to be absolutely perfect. Like even if you look at the key, the ones that I draw are not like point for point perfect. But I would like to see that your intercepts, that your graph at least goes through the intercepts that you write down. Okay? So this is what your homework problems look like. They're going to give you an equation. If you look at day 7 and day 8, they give you some equation. They ask you to sketch a graph that includes the asymptotes, and then you'll need to write what the intercepts are. Now, for these, you might be thinking that, shoot, this is going to take forever because I'm going to have to throw my y equals, look at the graph, make a table, all that kind of stuff. We should be able to figure out what our asymptotes are just by looking at the equation. So if we look at number 1, y equals 1 over x minus 4, what do we already know that x cannot equal? Right, x can't equal 4. So we should sketch in, and we sketch an asymptote with these dotted lines. That's how we know that it's an asymptote. So you should sketch that in at x equals 4. Then what about our y asymptote? What will it y never equal? 0. Yep, so right on our graph, we can just put y equals 0. There's not really a dotted line to sketch in because it would be our intercept. So I can write it on here. One of our asymptotes, and then just y equals 0 would be the other one because there's nothing going on at the end of our equation. Now, let's talk about, probably before we sketch a graph, we probably want to look at what the intercepts are just to make sure that our graph is, so we don't have to like sketch a graph and then erase it because we didn't quite go through the right intercept or something. If we look at our intercepts, is this ever going to cross the x-axis? No, because y equals 0 right here is one of our asymptotes. So it'll approach the x-axis, but it will never cross. Yes. Now, what about our y-intercept? We know that, this is just x, so we know that our graph is going to be something looking, across from each other. It's going to be those diagonals. So it will cross the y somewhere over here. And how did you find that? Did you look in your table? Yeah. So we can look at our table, or we can just plug in. In this case, it's really easy just to put 0 in for x. Zero minus 4 is negative 4, so we have a negative 1/4 would be our y-intercept. Yep. Look at our table or plug it in to solve. So what? What do you mean? Well, like if we look at our graph, we have an asymptote right here on our x-axis. So that means both sides will approach the x-axis, but it will never cross. Right? Just like with here at x equals 4, it'll approach this line, but it never will cross it. It never will touch it. Yeah. So if y equals 0, where this x-axis is our asymptote, then we don't have an x-intercept because it never will cross. Yeah. Yep.
So it's like when it has the fraction number that's like added to that number is the y, right? What y equals?
When you're talking to find the intercepts or to find the asymptotes. So we look at under here to find what x cannot equal, just like what we have been doing. So x can equal 4, so that gives us this asymptote. And we look on the outside to see our y asymptote. If it was plus 1, we move up 1, like we did in the second or third example. Or first or second. For our intercepts, we're going to have to do a little bit of work, right? For our x-intercept, we know that y has to equal 0, so we plug 0. For our y-intercept, we know that x has to equal 0, so we need to plug 0. So you're going to have to do a little bit of work to find the intercepts. What